So this past fall at the NeurIPS conference, Ilya Sutskever said that we are in a world that has data as oil. We are in a world where data is running out, and that phrase has been haunting me ever since. I want to suggest a pathway to more data. Right now, large language models can get trained on something like 1 trillion tokens of very curated text. It's not the whole internet. I mean, you can start with the whole internet, but it's not like clean, curated text. There's problems, though. That's a static snapshot. The internet continues to grow. There's also, of course, larger training sets of private data that are generated all the time. So I asked myself, what kinds of breakthroughs are needed to lead to useful data, not total data, but useful data for large language models? Basically, what is the scaling framework to move from 1 trillion tokens up past 10 trillion tokens and beyond? This is what I want to talk about today. If we scale to 10 trillion tokens in our training data set, we're going to need to do multilingual. We're going to need to do very focused, curated expansion of historically underrepresented texts. We have to go beyond our English-focused text corpus or body for these LLMs to a much more multinational one. It has to be not 80% or 90% English, but like 30, 40% English. A lot of Chinese, a lot of Hindi, a lot of French, a lot of Spanish. It has to more represent the world's actual language set. We also need much better curation tools. We'll need to automate cleaning. We have to have better deduplication pipelines that handle diverse languages and formats. We have to have more flexible tokenizers that adapt to morphological differences across languages. And if we can get there, models are going to become much more truly multilingual, and they'll capture a broader range of our expression. I will say, as someone who knows Indonesian, that the model doesn't feel as natural in Indonesian as it does in English. And that would make sense because ChatGPT and other models are mostly trained on English data. And so, to me, the simplest path to 10 trillion tokens is actually making the training set truly reflective of the languages that we speak as a global community. Let's go a step farther. What's the path to 100 trillion tokens in our training sets that are high quality? I think video is obvious here. Real-time web streams, continuous ingestion of high-quality web content, social media streams, getting large-scale transcription going of good quality podcasts, of phone calls, obviously with permission if they're high quality, and multimodal as well, like getting vision involved where we have high-quality vision tokens. Those are all pieces we have to cobble together to make the jump from 10 trillion to 100 trillion tokens. It's going to require an immense amount of compute, a lot of storage, huge network capacity. It's going to dwarf anything we've got today. And it's going to take transformers that can absolutely unify text, images, and even videos in the same architecture. We are just now getting to truly native multimodal architectures for text and images. I know text and images and video are on the horizon at OpenAI, but it needs to be scalable. And if we're at 100 trillion tokens and we have continuous feeds, it means that it opens the possibility of continuously updated models that stay current on world events. Don't ask me quite how we architect that. I think that's 2 or 3 jumps beyond what we have now. It's okay to dream a little bit. I'm mostly trying to color in roughly what it would take from a tokenization perspective to get there. Let's go beyond. What's past 100 trillion tokens? If we get into the quadrillion space for tokens, or 10 to the 15th power, we're talking pulling in sensor logs. This is where robotics starts to come into play. I know a lot of folks have been very excited about robotics getting into the physical space because embodied experience should dramatically expand our healthy token input selection for LLMs. So sensor logs from cameras, LiDAR, tactile sensors, motor commands, Internet of Things and wearables, and being able to pull all of that in again and actually train it as a good quality token so that we can actually train, understand, embody that understanding and output. It would take even bigger GPU and TPU clusters. It would take systems that can learn from interactions and unlabeled sensor streams. It would take tools that can compress raw visual and audio frames into tokens that are semantically meaningful. And they would have to do all of this at an unheard of scale. So again, that's yet another set of technical challenges we'd have to overcome. And then if we want to go even farther, get into zettabytes, like 10 to the 20th tokens and beyond, now we have to look at three-dimensional scans. We have to look at full audio streams, simulation logs, Internet of Things sensor data at city scale, data across multiple industries in real time in standardized formats, healthcare, manufacturing, agriculture, autonomous vehicles. Our infrastructure has to handle tens to hundreds of zettabytes. We need to have modular architectures that can handle multi-trillion parameter scales. It's an absolutely mind-boggling task. So there, in just a few minutes, I've taken you from where we're at now with trillion token models up to 10 trillion tokens, up to 100 trillion tokens, up to quadrillions, and then to the zettabyte era. I don't know when we'll get there. And one of the interesting things is I don't know if we have to get there for artificial general intelligence that's meaningful. If you think about it, it is notable to me that Clairvaux was saying that product requirements documents are actually higher quality in general without reasoning models. In other words, the stuff we have right now, the models we have today, the 4-class models we use, good enough for that piece of work. That doesn't mean I'm under the illusion that we have good enough models for everything else and all general purpose work. Obviously not. We have other things to do. But I don't think it's eminently clear that we need to get to zettabyte scale in order to have general intelligence or even to unlock superintelligence and start to kick off a chain reaction of intelligence that's self-improving. We may be able to get there sooner. One of the reasons we may be able to get there sooner is the reasoning scale model, which doesn't even touch any of this. You can scale reasoning by scaling compute at test time, obviously, regardless of the training data set size. And so imagine having a much, much smarter trained model at the 10 trillion or 100 trillion token scale, and also layering reasoning on top of that as a second scaling law. And so when I think about sort of the path to the next few years, I think it makes a lot of sense to be really honest about some of these big Lego blocks that are steps along the pathway to artificial intelligence scale. We need to be honest that we have barely scratched the surface of high quality tokens, but at the same time, getting 10x, 100x, 1000x, and more high quality tokens is going to be very, very difficult. It's going to be difficult from a research perspective, just understanding how to do it at scale. It's going to be difficult from a industrial data management perspective, building the data centers, ingesting the data, cleaning the data at scale that we've never touched before, et cetera. It's going to be difficult from the perspective of serving these models because they're absolutely huge models to serve. And we have that sort of cross-cutting factor of reasoning where model makers will have to decide how big do these models need to be in order to be useful to do economic work, especially if you can use reasoning as a sort of cheat code to scale up. This is what was on Satya Nadella's mind when he was talking about the value of being a renter in the gold rush. He was talking about Azure and how he wants to rent data centers to people who are interested in models and model making, and implicitly was saying he was kind of out of the model making business as just a Microsoft project. I think he was seeing the immense data costs here, and he was like, you know what? I'd rather just rent these guys all the data centers they need. That's a money-making proposition. Because if you think about it, this is an immense amount of effort, scaling up data like this. And the value you get is something that you have to continue to accelerate in order to harvest. OpenAI is right now riding the tiger's tail. They have gotten a little lead through 01 and 03. And they need to continue to hold on to that lead in order to continue to make the case to monetize for enterprise. So they are locked into the poker betting cycle for model makers. They can't get out. And I think Satya looked at that and was like, that's a very expensive game to get in. you can put all of this investment in, and then you have to be locked in to keep doing more and more and investing farther and farther, because right behind you are people like DeepSeek who are relentlessly distilling models down, and people like Qwen who are distilling DeepSeek models. And I think there was another Chinese model today that distilled even further. Now you have tiny, tiny models, like billion parameter models or less, that are really, really good. And those are only possible because of the original training work that was done on the 4-class models. But the fact that you can train once and then distill across the world means that you only can harvest the value of these models if you keep maintaining your edge, if you keep growing and growing and growing and maintaining your edge no matter what. And so when I look at this token ladder, up from 1 trillion tokens where we are now to the Zettabyte era, what I think of is OpenAI is kind of locked into this arms race. Anthropic is locked into this arms race. Gemini is pretty locked into this arms race. Arguably, Meta is locked into this arms race. And whether they like it or not, I think some of the Chinese LLM model makers are locked in as well. They all need to get to the winner's circle, and they don't know how to define that, and they only know they have to keep climbing. And that's very good for consumers, and that's very good for builders. But there's immense technical challenges coming up here, and I'll be really curious to see how they balance the challenge of getting into these new high quality tokens versus reasoning. One more thought I'll leave you with. This entire ladder is very friendly to NVIDIA. It's friendly in terms of GPUs. It's friendly in terms of the wearables and the LiDAR and the robotics that has to happen for some of the later stages with sensors. You're not going to get robotics at scale, I think, without some kind of NVIDIA stack underneath. And I might be wrong. Maybe there'll be another company that will come along that will be able to scale up GPUs and scale up sort of sensor collection. But my gut says NVIDIA is already here with their big robotics push at the beginning of this year, and they intend to relentlessly build into this space the way they've relentlessly built into a bunch of other spaces in the past. So we'll see. Anyway, some late night thinking on where we're at with data. I don't want to sit there and say that data is oil and we can't go get more. I want to think about the world in terms of tokenization, and I want to get more creative. So you tell me.